In this episode of Keen Academy, we'll be looking at section 1.3, Displacement in Two Dimensions on page 29, question number 9. Let's take a look at the question. It says, an airplane flies 1,512 kilometers west, 19.3 degrees north from Toronto to Winnipeg, continues 571 kilometers west, 4.35 degrees north from Winnipeg to Regina, and then changes direction again and flies 253.1 kilometers west, 39.39 degrees north from Regina to Saskatoon. And we're here to find the total displacement of the plane. So on to our givens. I've labeled the displacement vectors of the airplane as 1, 2, and 3. What we're trying to look for is the total displacement of the airplane. And how we're going to do this is that we'll be using the component method for the addition and subtraction of vectors. And you'll commonly see this when there are 3 or more vectors and you're just trying to add or subtract them. Here's how we're going to do this. We are going to solve for the x and y components of all of our displacement vectors. So let's begin, starting with displacement number 1, which is 1,512 kilometers with an angle of 19.3 degrees west to north. In order to find our x component, we're going to use cosine ratio as we're looking for the adjacent side of our right angle triangle. Put into the calculator, we're going to have 1,512 cosine 19.3, which is 1,427.027 kilometers. And for our y component, we're going to use the sine ratio because we want the opposite side this time. So let's put it in, 1,512 sine 19.3, that'll give us 499.738 kilometers. Same goes for displacement number 2, which is 571 kilometers with an angle of 4.35 degrees west to north. We're going to use cosine and sine again, so we're going to end up with an x component of 569.355 kilometers, and for the y component we're going to end up with 43.310 kilometers, and this is for displacements 1 and 2. On to our last displacement vector, displacement number 3, which is 253.1 kilometers with an angle of 39.39 degrees west to north. X component we're going to use cosine once again, and y component we're going to use sine. Put it into our calculator, 253.1 cosine 39.39 is going to give us 195.607 kilometers. And for our y component, 253.1 sine 39.39 is going to give us 160.616 kilometers. What we're going to do next is add up all of our x components and all of our y components. So since all of our x components were facing in the west direction, they are all going to be positive. So let's add them all up. Displacement number 1 was 1,427.027 kilometers plus displacement 2, which was 569.355 kilometers. And we're going to add that with displacement number 3, 195.607 kilometers, to give us a grand total of 2,191.989 kilometers west. For our total y component, we have 499.738 plus 43.31 plus 160.616, giving us a total y component of 703.664 kilometers. To find the total displacement of our airplane, we're going to use the Pythagorean theorem using our x component total and our y component total. So we have root 2,191.989 squared plus 703.664 squared, and that's going to give us a total displacement of 2,302.164 kilometers. We're now going to solve for direction using a tan ratio because we have our opposite and our adjacent side. So it's going to be 703.664 divided by 2,191.989, and then we are going to use inverse tan ratio of 0.32101, which we just got, and that's going to give us an angle of 17.797 degrees west to north. That concludes this episode of Keen Academy. So for more helpful tutorials on textbook questions, go look up Keen Academy on youtube.com.